So in this section, we're going to be working on some pretty basic and understandable properties, where we're going to get some introduction to mathematical notation, in particular with them, where we're going to learn that something very fundamental about math, in particular math notation, how we write things, how we express our values here. It can sometimes come across as a bit unclear for how specific it is, which might sound a bit oxymoronic, but you'll see what I mean when we talk about these definitions here, where their properties, they're fairly easy to understand, but it's a little bit trickier to say precisely what they mean. Where we say a function is increasing, in particular, increasing on an interval I, open interval is usually how we define these things, if for any x1 and x2 in I, such that x1 is less than x2, f of x1 is less than f of x2. Like I said, it's very specific. It's not quite helpful for how specific it is, but it's a lot easier if you have something like a picture to be able to understand what's going on. That what we're saying here is when we have x1 less than x2, we're saying we're moving to the right. We're looking at values that are going up in our input. We expect to see values that are going up in our output. That is, as we move from left to right, we're also going from down to up. Well, we're going up is the point, and this bit here with the notation is just a very specific way of saying that. It's a very specific way of saying exactly what's going on there in terms of our function inputs and our function values. A function is said to be decreasing in very much the same way, where if we're looking on an open interval I, and we have points x1 and x2 such that x1 is less than x2, then what we should expect for a decreasing function is that f of x1 is bigger than f of x2. And again, super specific, not entirely obvious, but we can understand if we see from a picture where what we have here is that as our x values get bigger, as we move from left to right, now the function is coming down. It's going from up to down. It's sloping downward, but we'll talk more about what slope means later. Again, a little bit easier to see than it is to specifically talk about, but it's still not that difficult to really understand once you actually have that in mind. And then finally, we say a function is constant if for any x1 and x2 on such an open interval I, f of x1 equals f of x2. That is, it doesn't change at all, and it's a little bit harder to describe, but this is by far the easiest one to see because it's just a flat line. And we'll talk more about that being, in particular, what's called a horizontal line, a constant function in that way as well, but for now, it's pretty easy to tell when something is constant. It just sort of flattens out. And to help with this just a little bit more, we're going to get an example here where our goal is going to be to identify intervals of increase and decrease in some general function. So for the function graph below, identify the intervals where it is increasing, decreasing, and constant. And again, there's those really specific ideas for what it means for something to be increasing, decreasing, or constant. Let's just think about whether it's going up, coming down, or not doing either, where we can see that the function is going up as it approaches -1 and after it passes 1. So we say the function is increasing using interval notation. So this stuff does come back in this context from -infinity to -1, but not at -1. I'll talk about that more in a second. Along with, so union, 1 to infinity. Similarly, if we want to figure out where it's decreasing, you just look at where it's going down. In this case, it's coming down, well, between those windows. So the function is decreasing from -1 to +1. Pretty clear there. And if we want to talk about where it's constant, those aren't actually intervals, and it's kind of hard to tell the values themselves anyway, but you can see there that it flattens out just a little bit. Right at the top of those curves, or top and bottom, excuse me, of those curves, where we can't really express those, like I said, in interval notation, so we don't quite say that it's the interval -1 and 1. It doesn't really work that way, but they are constant in terms of function behavior at those specific points. And when you get on to calculus, for those of you who are going to go there, you're going to see that those are very specific and important values to note for a thing called the derivative that we're going to get hints of more throughout this week because of other things we're going to be looking at. But in particular, those values there where the function changes from increasing to decreasing in that nice sloping way, have a special name where they're what are referred to as relative extreme values. And that's what we're going to be talking about next.